So how to smooth an image? Now, before we talk about smoothing an image, we need to understand clearly that an image is nothing but numbers. An image is nothing but a matrix of numbers. So an image that looks like this, which we visually perceive as objects and images, in reality, in representation in computer, is nothing but a matrix, something like this. To get a deeper feeling that an image is indeed a matrix of numbers, let's look at this. I have a notebook where I'm going to upload a grayscale picture of a cat. And what I'm doing here is loading the image and then resizing the image to a smaller dimension of 128 by 128, so I can do processing more quickly. And then I'm converting the image into grayscale. So let me run this cell. And then what I would like to do is print this image. So here's my 128 by 128 image, and it's a picture of a cat, and it's a grayscale image. Now next, what I would like to do is look at, so this is my gray is my variable that has the image that I'm showing using IMShow. And if I print the first 15 numbers of x and y, that is this corner right here, all I see is numbers. In this case, smaller numbers represent darker pixel, and larger numbers represent lighter pixels. So here all of these larger numbers indicate that these are the pixels in the upper left corner of the image. Next, what I would like to do is convert this NumPy matrix into a CSV file and download it to my computer. So I have my downloaded CSV file. What I'm going to do now is open it with a text editor to see what it contains. As you can see, it's all numbers. So here's my first line indicated by 1 here, here's my second line, and so on. Next, I would like to open this file using Microsoft Excel. Excel can pretty easily load the CSV files, and next what I'm going to do is select all of my cells and color them by intensity. So I'm going to select conditional formatting, color scales, and give green colors to higher color to lower intensity values and lower color to higher intensity values. So you can see that what I have now is that each number is sort of associated with, is given a color corresponding to the number's value. So I'm going to select all of these cells and then square my cells here so that my height and width of each of the cells appear exactly same. So I'm going to make each cell a square. So what I have now is each cell is a square now, and as you can see, I can already see that the numbers already represent the picture. I'm going to zoom out a little bit more, zoom out further more, and you can see that the numbers and the intensities assigned to these numbers already represent the cat picture that we had. I'm going to zoom out further, and now you can clearly see the cat picture. And if I decrease the font to a smaller font, let's say 8, then I can even see the numbers associated with this matrix. For example, at darker values, you can see that the numbers are very small, and in whiter areas where my intensity is very low, I can see that the numbers are very large, as you can see in the text field here. So this is how image is a matrix, and a matrix is viewed as an image. We view a matrix if it represents a real world object as an image. Going back to our question, how to smooth an image? The idea behind a smoothing image is pretty straightforward, and it's pretty simple. The idea is that we assign each pixel the average of its neighbors. That is, if this is my input image, it is possible that some of the values may be extremely big. Maybe this number is 13, maybe this number is 17, which is nothing but error. or it's like a noise in my image. So the idea of a smoothing image is to remove such noise or have lesser effect of those noise. So the idea is that what we would like to do is assign each pixel the average of its neighbors. What this means is, say for example, this is my input image, and here's, let's say, my smooth image that I would like. And let's say for this pixel, this number 6 here, what I would like to do is smooth it. So the idea behind smoothing is to create a new pixel value for this number 6. What I do is I look at all the neighbors around 6 and simply take an average of all the values. That is average of 301, 262, 241, and put it as the final value in my cell. So for example, the next number 2, for it, the value that will go into here is the average of all the numbers around it. And similarly, number 4 will go in as the average of values around 4. So this number 4 will go in as the average of all these 9 numbers. So this is pretty straightforward. In other words, if there is an extreme value, because we are taking average of the neighbors around it, the extreme values will be, the effect of extreme values will be smoothed out. A few follow-up questions. So how to calculate the average for corner values? So say for this number 3, where I don't have neighbors in top left in these regions, how do I calculate the average? There are one simple way to come up with the solution is we do not calculate the average for the corner values. So all the values in this first column, all the values in the last row, last column, and first row will not have any output. So if my input image is of size, let's say 35 by 35, then the output will be 33 by 33, because for the corner values, the first row, first column, and last row, last column, I cannot produce any output if I'm using a 3 by 3 size neighborhood, right? So then the question is, will the output size of the image decrease? Yes, depending upon how big neighborhood we look. If you're looking at only one like a step of the neighborhoods, then our matrix can decrease by size 2. From 35 by 35, it can go to 33 by 33. And the next question is, how many neighbors should we consider? So the question is, so I'm currently assuming that for this number 6, all the neighbors are equally important, and I'm averaging, right? So say I'm looking at this number 3, then I will be considering this rectangle around 3. The question is, how many neighbors should I consider this, or should I consider a bigger neighborhood size? What neighborhood size should I consider? That's another question. We will answer that. So the answer for how many neighbors should we consider is that instead of looking at all the neighbors equally, what we do is we calculate weighted average, such that we weight the most nearest pixel, that is the pixel which we are calculating, give a very high weight, very high weight. The pixels around that have lower weight, and the pixels further around have much lower weight, And this weight matrix, that's going to weight the center pixel very high, pixels around that slightly lower, and the pixels around that much lower is known as a Gaussian filter. Here is an example of such a filter. This is a 7 by 7 Gaussian filter, an example Gaussian filter. And it's a Gaussian filter because you see very high intensity in the middle, and in the next level the intensity is slightly becoming lesser and lesser, and so on. And at the most outer level, it's almost zero everywhere. Now remember, this is not an image. Instead, it is a multiplier, a filter, a matrix that multiplies with the image. So once we multiply this with image every pixel, so at each pixel we take this Gaussian filter, apply it to the image, and then get a smooth image, a smooth image. For simplicity, I'm going to create a filter of size 3 by 3, and this is not a Gaussian filter because the intensities are not going slowly, high in the center and smaller on the outside. But I'm just taking a simple filter as an example to demonstrate how filters work, how such multipliers or such matrices work. So let's say I have this image, here's my intensity values, and here's my ND, this is my Gaussian filter. Now what I would like to do is multiply, this is a convolution operation, also known as convolution operation. Take this filter, multiply this with the image and produce a smooth image, smooth output image. So the first thing I'm going to look at is take this pixel as input and try to multiply this with its neighbor, that is this neighborhood, with this is a, we need a 3 by 3 to multiply with my 3 by 3 filter. I don't have the values here. For simplicity, I'm going to skip this. I'm going to look at 40 again. Again, I don't have enough neighbors of size 3 by 3 to multiply with my filter. I go all the way to 50, I don't find anything. I take 40, also nothing. So when I try to filter this number 40, I have enough neighbors. So I have 3 by 3 matrix around this 40, which I can use to multiply with this filter. So now to smooth out this number 40, I'm going to multiply this 3 by 3 matrix with this 3 by 3 matrix element wise. In other words, I'm going to multiply 35 with a 0. So 35 times 0, this gives me a 0. I multiply 40 with a 1, this gives me a 40. I multiply 41 with a 0, gives me a 0. 40 with a 0 gives me a 0. 40 with a 1 gives me a 40. Another 0, 0, 40, 0 and 0. So if I sum these up, so I can either take an average of 9 or I may not take average. Either way, whatever this number comes out is my smooth value for my first pixel. So these pixels I will not obtain, the outer pixels I will not have the values for them because right now I'm skipping them. So my smooth image from this 5 by 5 picture will be a 3 by 3 picture, and right now we have obtained the first value. To obtain the next value, I'm going to slide this 3 by 3 matrix one position to the right and then obtain the smooth pixel value for the next pixel 42 and fill it up over here. So I can repeat this from left to right, go one step down and calculate this one, and continue to get all the values in this filter, in the output image. Overall, this application of the Gaussian filter replaces the intensity I x naught y naught. So say for example, I'm looking at this intensity value 50, which is, let's say, my I x naught y naught. Then what it does is it replaces this x naught y naught with the sum over all the xy pixels. Now when we say xy, we're looking at this neighborhood. Sum over all the xy pixels where each intensity, so any pixel x, I, x, y, which is the neighborhood of this I, x naught, y naught, is multiplied by nd. So d represents how far you are off from your center, from your value. In this case, d equals to 1 might mean that what is your intensity in the next level of neighbors around you. So you multiply each intensity with the weight for that intensity, and what comes out is the sum of all the I, x, y times nd values gives you the new intensity for this current intensity x naught, y naught. Such a weighted sum is also known as convolution. In deep learning, this process of multiplying an image with a filter is also known as the convolution operation. As an example, I would like to use Excel to demonstrate how averaging pixels around the neighbor can smooth an image. So here I'm going to take the first pixel and sort of take the average of all the neighbors around it. So the pixel here is equal to the sum of pixels from A1 through C3, which is highlighted in the corner over here, and I would like to take the average and divide by 9. So this gives me the pixel value, smooth pixel value for the first pixel, and I'm going to drag this so that this applies to all the pixels in the first column. And I can also sort of drag it in the horizontal space to get the values for each pixel in all the rows. So now this gives me all the values. We can even look at these values to see how they look like. Now these values are extremely large in font, so let me try to decrease the font further, maybe make it 6 so that I can see the numbers. So now I can see the numbers, and these are now smoothed out numbers. So let me again visualize these numbers using the same kind of coloring technique that I had used earlier to see if this matrix is slightly smoother or not. So I'm going to do color conditioning, color scales, and choose the same. So you can see that there is some overlap because I over dragged on this side, but you can see that the second image that we have here is clearly more like blurred or smoothed out version of the first image. So just by I did not apply any big Gaussian filter, but the same technique can be used to come up with many kinds of output images, maybe even detect edges, come up with more smooth versions of images, and so on.